Hi, this is Chong Kim, and we're going to do word search in Scala. So let's take a look at the input first. Our input looks like this, where we have a block of letters. We have a list of words that we're going to search for. A question mark means that this is some character. It'll match any character, and we'll find words going across, down, diagonally, and also it'll snake around, just like the game Boggle. So you see that there's rocks over here, but there's also rocks, ROC, and then there's a K down here and an S over here. And that allows that word to be found because it'll snake around. All right, now that we know what we're going to do, let's start with the first project, the first part, which is, well, let's just get it to print hello. All right, so first thing we do is we create a singleton object called wordsearch. Main, it'll take args, which is going to be an array of strings. We'll just print out hello. Oh, and we're going to modify Vim so that whenever you do a buff write, it'll at the end, after you finish writing the file, writing scala wordsearch.scala, it will go into the shell, which is the colon bang, means to go to the shell, and run it. So scala wordsearch.scala with the argument input.txt, which is the input file in the directory above. All right, so let's test this out. It should say hello right now. Okay, there it is, hello. So everything is working properly, and the first thing we're going to do is we're going to read the file. The file can be read from scala.io, source, from file. And this takes a file name. And the file name is passed in through arg0. And to read it, we just do make string, and that'll read the file. Well, let's just print this out. So println of this, we should see the file. Okay, so we ran into a problem. Let's see what the problem is. Okay, let's see if it, oh, we're not in the right directory. It didn't find the file. And the reason why is because we're still in word search. We need to go into the Scala directory. So move that into the Scala. All right. So check out the other video on Ruby if you have a chance. Okay, so let's try that again. Okay, and we'll set up the little task here. So whenever you do a buff write at the end of when you're saving wordsearch.scala, go to the shell and run scala word search on input text. So I save. This time it found the file and everything is working, so this is good. All right, so we have the file and we need to split it on the empty line because it's broken up into two parts. The above is the grid, and the second part is the word string. Okay, so we can't just assign it like this. We have to destructure it because this returns an array. So we have to destructure it by saying array containing these two items, and let's just check. Okay, it works. So we have these two things, and what we're going to do first is create a grid line. And what a grid line is going to do is going to store a list or an array, where it looks like it'll contain each line of row and column information, which is the grid coordinate. So like, for example, 0, 0, and followed by the character. So it should contain a whole bunch of these, a list of these for each of the lines. Okay, so we can do the transformation by starting with the grid. Okay, and we can print it out as we're going along. So grid line. Well, okay, let me print out the grid line first. First, I'll split it on the new line. So this is a list of lines now. Okay, when I do this, you'll see that it says that L is for a list. So it's a list of strings. And this is not very useful. So if you do make string, it'll convert it into something more readable. And there it is. But when you do make string, it could also take in an argument, which is the delimiter. And I'll choose a, I could choose a tab, for example, so that you can see now that these are each of the lines. I could also do new line if I wanted to, and see it this way. This is probably better. Okay, so let's do the transformation. So this is a list of word lines. Then I am going to do a zip with index, and it has the line and the row. That's good, and we need to do a map on it, and we'll just say case, and that's a line. Follow, it's a tuple, so it's a line and a row. And for now, we're just going to what we want is to have a list of these things of row and column information, but we don't have the column information yet, so we'll just put a 0 for now. And we don't have the character, but so we'll just put the line, and we'll replace this once we have the actual data. So let's see what this looks like. Okay, so it'll be like this, except that it'll go across the line for each of the characters. So that we do that by doing starting with the line, we do a zip with index. Oops, map. Okay, in this case, when you do the zip with index, mapping across the line will give you a character, and the second part of the tuple will give you the column. Okay, so we have all the information we need now. So we replace the 0 with the column and the line with the character, and we close the curly brace. And this is what we want. So we want a list of lines which contain the coordinate and the character. The reason why we want it this way is when we do the output. So let's do the output here. So okay, we can get rid of this print statement. So with the grid line, you're going to go across, and this will give you a list. We'll just say that case grid line. When we go across, we want to take that grid line and map against it, and this time it'll look like this. It'll look like destructuring it. We have row column information followed by the character. Okay, and for now we'll just put a dot. Okay, and wrap this in a println. Okay, it's showing something not very useful, so we'll need a make string, and we'll use the new line as the delimiter. Okay, but we don't want it to look like that, so we'll just take this list and do a make string on it. So if we, let's see what we get when we do a make string. Okay, now it's dots, but we're going to use a space as a delimiter so it'll look nicer, more spread out. Okay, this is great. So what we're going to do is we're going to conditionally print out either a dot or the character, and we're going to do it based on the mark. So we'll say mark is equal to a list that contains 0, 0 and 1, 1. So we'll say if mark contain, if it contains the row column information, the position, we want to use the character. Otherwise, we'll use the dot. And okay, I think we can just save. And there it is. So here's 0, 0 and 1, 1. So we have our input taken care of. We have our output taken care of. We need to just do the middle part and figure out what exactly we need for the mark. So first, we're going to just comment this out, and for the mark, we'll just print it out just to see how it looks like as we're going along. So we'll just say println mark that make string, and let's start with the list of words, or the word string. So we're going to transform the word string into the coordinates of where those words were found. Okay, so start it with the word, and we'll see that it's just a string. Okay, and we notice something about this. We notice that we'll have a hard time because there are some that are in lowercase. So what we can do is over here, when we do the make string, we could once we made the string, we can say to uppercase and convert everything into uppercase. So now the whole input is uppercase, and now we don't have to deal with lowercase letters. Second thing is, you may not notice it, but there's actually a space here. If I split it on the comma, okay, and see, yeah, well, you don't see, if I split it on the comma, I'll just say use the delimiter dash dash. So you see that there's spaces over here. There's space here, a space here, and a space there. So we need to get rid of the spaces. So after we split it, we run it through a map, and which means that we're going to do it for each of the characters. And we're going to say underscore represents that element that we're looking at, and say trim. And let's see. Okay, now we got rid of the spaces, so we're all good. And, all right, so we have the strings now, and we're going to go through each of those. So after you do a trim, we're going to do a search on that word. So search. We haven't written this function yet. Okay. So for now, what we can do is just create a search function here. Okay, I just turned off wrapping, so it doesn't wrap around and look so ugly. Okay, so let's create a search that takes in the word, which is going to be a string, and this is going to be a function, so we have to have an equal sign. And the return type of this, we say a colon to specify the return type, is going to be a list of positions. So it's going to look like int. Okay, so it's going to have a list of these things. So we're just going to hard code this for now. We're going to say list of 0, 0. All right, missing parameter type of on trim. Okay, so let's make this a little bit more explicit. So you say case word string. Actually, we'll just start with this. Search on the word. But then we trim it. Okay, a little bit better. So, okay, so you can see that there's a bit of redundancy here. And what we can do is we can say distinct. Okay, let's see what happens. And there it is. So it'll get only unique ones. So list of 0. All right, so it looks like everything is working. So that means that all we need to do is just turn this into something real. Okay, so let's think about all the things that we need. We need to have the grid information because, and the type of the grid is going to be, it's a map. And the key is the int comma int, which is a row column position, and the value is going to be a character. Okay, so that takes care of the grid. So let's pass in the grid over here and search. This might start getting long, so let's just start wrapping it. Let me just break it up. Okay, so given we need the grid. So how do we get the grid to be in this form? Well, we'll start with the grid line. And we can okay, starting with the grid line, we can say flatten. And that will collapse a list of those list of positions to just a list of positions. And once we have a list of positions, we can just say to map. And that should convert it. So let's make sure that it passes. We have a type conflict here. No, it's not a type conflict. It says that error, parentheses expected, but open parentheses found. Oh, that's because when you specify a type, you're using like square brackets instead of parentheses. Okay, so it works. Okay, what else do we need? We also need to know what grid position we're starting from. So we need to actually modify this so that it runs through all of them. It starts from, well, we need to have the grid line. So actually, it seems like we probably need to okay, so let's just make a grid. Val grid is equal to okay, so we have the grid, and we start with the grid and get all the keys, and then we say map. So this will give us the row column information. So we're going to go through all the positions that are in the grid, and we're going to pass that in, RC. Okay. All right, so this looks good, and let's check this out. Okay, too many arguments. Oh, we didn't modify it. We need to include the RC, the row and column information, and the type is going to be int. It's a tuple. Okay, so it returned us a set. Okay. Okay. So, okay. I think, yeah, I think set should be okay. If we really wanted to, we can also convert it back to a list. But it seems like, oh, it's a list of a list. Right, because it's going through each of the positions. So instead of using map, we need to use flat map. Flat map. Okay, and let's see. Okay, list. Okay, so that's if you wanted to have it as a list. Okay, so just to make sure like the RC is running through all of them, the row and column information RC, we'll just say return a list with RC. We should see all the positions, and it's a list. The keys are not in order, so this looks like it contains everything. So we see 9.2 and 9.8. So eventually, if we look hard enough, there's probably a 9.9 and a 0.0. Okay, so it looks good so far. And okay, so let's actually start the code. When do we know? Oh, one last thing. We need to keep track of where we are. So after the word, we're going to pass in a nil. Nil represents, well, it's the same thing as an empty list. We could also do it like this, and that'll be an empty list. But we'll just say nil. And in the search, we'll add over here to the last argument, the path. The path is going to be a list of, oh, brackets, int, close bracket. Okay. All right, so this looks pretty good. We have the grid, the RC, word, and path. Okay, I'll make the font a little bit smaller here so it'll fit more. Make it a little bit smaller. Okay, now everything fits in. Okay, so we have all the parameters here now. Now, let's think about our base cases. Well, what we're going to do is every time that there's a, we start off with the original word, and then when we go look for the rest of the item, we're going to chop off one of the letters in the word. So let's start with a, how do we know when we're done? Well, when we're done if the word is empty. That means it's successful. So if it's successful, then we just return the path. Okay, and if and these, let's think about some cases where it would be unsuccessful. Well, it would be unsuccessful if the RC, actually we have the grid keys, and we can check to see if the RC is inside of the grid, contains RC. Well, if it doesn't contain it, then we're going to return nil, which is an empty list. Okay, so that's one reason why it should terminate. It terminates if you go out of bounds. Another condition is if you've already been there, and you can do that by looking at the path. Contains RC, the row column. Okay. Another reason why you would stop is if the letter doesn't match. So we can test by saying we can test on the head of the word. And what this does is if I have hello and I say a dot head, that'll give me the H. But if I say a dot tail, it'll give me the rest. Okay, so this is the first character of the word, and let's test this against these two items, and then we'll just say it contains. Actually, not contain. Okay, so what? If it's a question mark, it's important to use single quotes this time, because if you use double quotes, this means that it's a string. But if you use single quotes, it means a character. And we're doing a head, and you can see that that when you did a head, it's a character that gets returned. So we need to compare it against a character. So actually, let's take a look at that. So if I had, for example, H compared to a character, it's false. So if I had used double quotes instead, it would give me the wrong result. Okay. The second is if you compare it with what's in the grid. So the grid RC position, and that will return me the character. So if these two conditions, either it's not a wildcard or it's not what's on the grid, then we know it's we're done. Okay. Third thing. Okay, this is where we do our main processing. Okay, so we have our terminating conditions, and now we're going to actually build the list. So, so we know it's not a terminating condition, so we're going to have to go to a direction. We also know that our first letter in our word matched. So we're going to look to go into all directions. And the way I'm going to do that is using a for. So let's take a look at for. So if I say 1, 2, 3, yield, actually I need a variable here, so x, yield x. Okay, so I get a vector 1, 2, 3. And if I have a y here that goes from 1 to 3, then I'm going to create a tuple that looks like this. So this is basically what I want, except I'm going to run through -1 to 1 and -1 to 1. Okay, and this will represent all the directions that you can go. Okay, so for I'll just call it R, -1 to 1, and column is going to go from -1 to 1. You're going to yield R comma C. So this is going to be the row and column. So for each of these, we're going to map it. We're actually going to do a flat map, because once we do it for each of them, we want to group them all together. So a flat map. Okay, so with the flat map, we have the RC. Okay, let's break into a new line. Let's put the curly braces there. Okay, so we have the RC, and we're going to search the grid at the new position, and the new position is going to be RC underscore 1, this represents the first element of the tuple, which is the actually I should wrap this in parentheses. So this represents the row part of the RC. It's one base, so it's underscore 1. And I'm going to add the R. And RC underscore 2, that's the second part, which is the column information, plus C. So this represents the new new position. Next is the word. I want to get the tail, so the rest of the word, because we know the first one matched, so we can just take that out. Next is the path. Well, we'll just add the path that we were just in. So we were just in RC, so we'll just add that to the path. Yes, I think it, yeah, 2 colons path. Okay, so that should take that should take care of it. Let's see what the result looks like. Okay, some errors here. Value contains is not a member of iterable. Okay, keys. Okay, so we'll just turn this into a list. Okay, next problem, it says return nil. That's because the nil needs to be capitalized. Yeah, this is getting kind of long, so I think I'm going to, actually I'll just keep it like this. Now I'll just move it like over here so you can see it a little bit better. I'll do the same thing with this. Actually, this one's kind of short. Okay, so let's see. Look at the next error. Next error is a flat map, because it's not spelled that way. It's spelled in camel case, so flat map. Okay, one error found. Okay, now we have a type error, flat map. Okay, so all right, so we should convert this into a list. Okay, so we have all the positions, and let's check. Okay, actually, let's take a look at it again. Okay, so we need to distinct list. We have the flat map, and well, okay, so what we're trying to do is looking at this, it's not exactly what we want, because it's a list of a list, and we want to group them all together. So there's a flat map that's missing from here somewhere. Okay, so this is a flat map, so this should be okay. And search is using a flat map here, and over here I think I should also be using a flat map. Let's see, and that looks like that did the trick. So now we have a list of positions, so we can actually test this out now. So we're going to take away the temporary print statement, we uncomment our output, we run it, and it works. So this is search word in Scala.